Next is question number 66, which says that if the function y equal to ax cube plus 6x is always an increasing function, then the set of exhaustive values of a is, as the given function is an increasing function, so we can see that dy by dx will be greater than equal to 0, that is 3ax square plus 6 is greater than equal to 0. Now, for a quadratic equation, we know that it can only be greater than equal to 0 in cases like this or this. That is, discriminant d should be less than equal to 0, right? So, the discriminant is b square, that is 0, minus 4 into 3a into 6 is less than equal to 0. That is, from here we get that a should be greater than equal to 0. Also, from the given graph, we can see that this is possible only when the coefficient of x square is positive. So, from here, the coefficient of x square, that is 3a, that should also be greater than 0. So, taking intersection of 1 and 2, we will get that a is greater than 0. That is what we get from here. But in the given options, we see that a equal to 0 is also given. So let us check at a equal to 0 what we'll get. When a is equal to 0, y is equal to 6x, which is an increasing function, right? So we can say that function y is an increasing function for a belonging from closed 0 to infinity. So the correct answer is option number 1. Next is question number 67, which says that the vertices of a triangle ABC are A, that is 0, 0, 0, B, that is 1, 1, 1, and C, that is minus 1, 0, 1. The equation of the plane containing all the medians of the triangle is, let us say this is the triangle ABC. Now, we want that these medians should be lying on that plane. Now, this is obvious that if the medians are lying on the plane, then the points A, B, C will also lie on the given plane, right? So, the question becomes very simple. That is, we know 3 points from which the plane is passing. Let us take a point on this plane, that is P, that is X, Y, Z. So, we can see that the scalar triple product of PA and CA will be equal to 0. That is, we can say that the determinant of PA, that will be X, Y, Z, BA vector will be 1, 1, 1 and CA vector will be minus 1, 0, 1. This determinant will be equal to 0, right? So, solving this, we will get X into 1 minus 0, that is 1, plus Y into minus 1 minus 1, that is minus 2, plus Z into 1 into 0, that is 0 plus 1, that is 1 is equal to 0. Hence, we get that X minus 2Y plus Z equal to 0 is the given plane that is given in option number 2. So, it is the correct answer. Let us now move to the next question, that is question number 68. It says that the multiplication when r is going from 0 to n, secant x whole raised to the power 1 upon 2 raised to the power r plus tan x whole raised to the power 1 upon 2 raised to the power r is equal to. Now, let us say this is equal to I. So, putting r equal to 0, we will get secant x plus tan x. Putting r equal to 1, we will get secant x raised to the power 1 by 2 plus tan x raised to the power 1 by 2 and so on up till secant x raised to the power when r is equal to n, that is 1 upon 2 raised to the power n plus tan x raised to the power 1 upon 2n. Now, here we can observe that if I multiply and divide the given equation by secant x raised to the power 1 upon 2 raised to the power n minus tan x raised to the power 1 upon 2 raised to the power n, In the numerator and denominator, we will get secant x 1 upon 2 raised to the power n minus tan x raised to the power 1 upon 2 raised to the power n. Now, here it can be observed that this term and this term, when they will be multiplied, that is a plus b into a minus b, it will give me a square minus b square. That is secant x raised to the power 1 upon 2 raised to the power n minus 1 minus tan x raised to the power 1 upon 2 raised to the power n minus 1. Similarly, that term will be multiplied with the previous term and so on if I repeat this up to n terms. So, this can be then equal to secant x plus tan x into secant x minus tan x. That will give me secant square x minus tan square x upon secant x raised to the power 1 upon 2 raised to the power n minus tan x raised to the power 1 upon 2 raised to the power n. Now, numerator becomes 1 and if I multiply it by cos x raised to the power 1 upon 2 raised to the power n, so in the denominator we will be left with 1 minus sin x raised to the power 1 upon 2 raised to the power n. That is, the correct answer is given in option number 1. Next is question number 69, which says that if a vector is equal to I cap minus j cap and b vector is equal to I cap plus j cap, then the vector c satisfying a vector cross c vector plus b vector equal to 0 and modulus of a vector minus c vector is equal to modulus of a vector plus c vector. Now, solving this equation, let us take its square on both sides. So, we'll get mod a whole square plus mod c whole square minus 2 into a vector dot c vector is equal to mod a vector whole square plus mod c vector whole square plus 2 times vector a dot vector c. Now, here it can be observed that these two terms will get cancelled on both sides. So, we can see that vector a dot vector c is equal to 0, which means that vector a is perpendicular to vector c. Right? Now, we are given vector a equal to I cap minus j cap. So, let us say vector c is equal to alpha I cap plus beta j cap plus gamma k cap. So, taking a dot c equal to 0, we will get alpha minus beta equal to 0. So, we can see that c vector is equal to alpha I cap plus alpha j cap plus gamma k cap. This is the c vector and we are given one more relation, that is a vector cross c vector is equal to minus b vector. This is also given to us. So, let us find a cross c vector. That will be equal to I j k cap and a is 1 minus 1 0 and here we will have alpha alpha and gamma. So, this is equal to I cap into minus gamma plus j cap into 0 minus gamma plus k cap into alpha plus alpha, that is 2 alpha. So, we can say that a cross c vector is equal to minus gamma into I cap minus gamma into j cap plus 2 alpha into k cap. So, this is equal to minus b vector, that is minus I cap minus j cap. Now, equating the coefficient of I cap, j cap and k cap on both sides, we will get gamma is equal to 1 and 2 alpha is equal to 0, that is alpha is equal to 0. Now, what we have to find? We have to find the vector c, that is vector c will be equal to alpha into I cap, that is 0, 0 into j cap plus 1 into k cap. So, from the given options we can see that option number 1 is the correct answer. Next is question number 70, which says that if A is equal to matrix 0 1 lambda 1 1 2 3 3 1 1 and similarly the matrix A inverse is also given and we have to find the values of lambda 1 and lambda 2. Now, we know the property that A into A inverse is equal to I, that is identity matrix 3 cross 3. So, let us multiply both the vectors. that is 0, 1, lambda 1, 1, 2, 3, 3, 1, 1 into 1 by 2 minus 1 by 2, 1 by 2 minus 4 lambda 2 minus 1, 5 by 2 minus 3 by 2, 1 by 2. Multiplying these two, it will be equal to minus 4 plus 5 by 2 into lambda 1, lambda 2 minus 3 by 2 into lambda 1, minus 1 plus lambda 1 upon 2. And here we will get 1 by 2 minus 8 plus 15 by 2. And here it will be minus 1 by 2 plus 2 lambda 2 minus 9 by 2 and so on. Right? Now this is given to be equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Now this is given to be equal to this. Now we have only two unknowns. So it is not required to find all the values of the matrix. From here only we can say that minus 4 plus 5 by 2 into lambda 1 will be equal to 1 and lambda 2 minus 3 by 2 into lambda 1 will be equal to 0. So we can say that lambda 2 is equal to 3 by 2 into lambda 1. So from here we get that 5 by 2 into lambda 1 is equal to 5. So from here we will get that lambda 1 is equal to 2. Now putting the value here, we will get that lambda 2 is equal to 3 by 2 into 2, that is equal to 3. So these are the two values of lambda 1 and lambda 2. So from the given options we can see that the correct answer will be option number 3.